Here's more or less how an idle scan works. First, Nmap sends an IP ID probe to the zombie to see what its current IP ID is. Next, Nmap sends a send packet to the target, spoofing the IP address of the zombie. Now let's assume that the port the Nmap is looking for is actually open. Since the target will think that the spoofed packet came from the zombie, it will respond with a send ACK packet back towards the zombie. If the zombie gets this, it will respond with a reset since it never sent the actual original packet. Since the zombie had to send the reset packet, this increments its IP ID. On the other hand, if the port the Nmap is looking for is closed on the target host, it will send a reset message to the zombie. When the zombie gets the message there is a bogus packet and gets the reset, it doesn't send anything else out on the wire, so thus its IP ID is not incremented. Based on whether or not the zombie's IP ID is incremented, you can tell more or less whether or not that particular port is open on the target. If the IP ID is incremented, then the port's open. If the IP ID of the zombie is not incremented, then that particular port on the target host is closed. Click next for a video showing how to find a good zombie host. You can use the -V and the -O options to do an OS detection on a host and print out verbose information. Normally you would scan a range of IP addresses to try to find a suitable zombie host. However, since I already know one that exists on this network, I'll just scan it and show you what the results for a good candidate would look like. What we're looking for is a host on the network with a TCP sequence that's easy to predict. As you can see from the output on the screen, we found a JetDirect box which should have a TCP sequence that's trivially easy to predict. Click next to see this host uses a zombie in an idle scan. Here we're going to use Nmap to do a port scan for the remote desktop port, tell it not to do a ping, and to use host 192.168.1.124 as our zombie. To scan host 192.168.1.100. Keep in mind that an idle scan will be slowed in Nmap's standard TCP connect or send scans. As you can see, the remote desktop port is open on this host. If we go to the Windows firewall log on the target host, we'll notice the only IP that shows up is the IP of the zombie that we used to scan that particular target. For a simple port scan, idle scanning is a great way to hide the identity of the true scanner. However, if you use more complicated options, like the -A option to tell it to turn on OS detection and version detection, more information is saved in the log, and this information can be used to trace back the identity of the true scanner. To find out more detailed information like what OS the box is running, or what version of services it's running, Nmap has to directly contact the box, thus leaving its own IP, the IP of the true scanner, in the logs on the target host. Using this log, the admin of the target host could possibly trace back the true identity of the person who was doing the scanning. Notice that the firewall log actually logs the IP address 192.168.1.101 as one of the IPs that was trying to connect. Click next to continue. Another cool feature that Nmap has is decoys. When the decoy option is used, Nmap will send smooth packets as the IP addresses that you specify. This will confuse the logs of the targets since they'll look like many different machines are actually doing a port scan, and the administrator wouldn't necessarily be able to figure out which IP address was doing the true port scan. Keep in mind if you use certain options like version detection or OS detection, and the admin spends enough time, they'll be able to figure out which IP address the scan actually came from. In the command I'm using, I'm choosing not to ping, using the -D option to tell it my decoys. I put an uppercase ME wherever in the order I want my real IP address to appear. I can put an IP address as a host name to the machines I want to act as decoys. As you can see from the Windows firewall log, my IP address appears in the log as well as those of my decoys. Click next to continue this tutorial. Nmap has too many options for me to cover even in 2 video tutorials. However, there are several I want to mention before I finish this presentation. -O allows you to do a protocol scan to see what protocols the host supports. For instance, it might tell you whether or not the host supports UDP, TCP, ICMP, etc., etc. --send_eth sends packets using raw Ethernet as opposed to a higher level like IP raw sockets. Generally, Nmap is pretty good at choosing what APIs to use to send packets, and normally raw sockets might be the fastest on Unix-based operating systems. However, my understanding is the Windows XP version of Nmap defaults to raw Ethernet. They do this because of how Microsoft has mucked around with raw socket support in Windows XP Service Pack 2 and later. The complement to this command line option is --send_IP, which tells Nmap to use raw IP sockets. --randomize_hosts randomizes the order in which hosts are scanned, thus hopefully avoiding some intrusion detection systems. It's pretty obvious that a port scan is going on when the connections proceed sequentially from one IP to the next. The randomized option breaks up this pattern. The --spoof_MAC option allows you to assign what MAC address it appears that the scan is coming from. A cool MAC address to assign is Dead Beef Cafe. The -S_L option tells Nmap not to do any kind of scanning, but just to do a DNS lookup on each one of the IP addresses in the range. This is a pretty useful replacement if you can't do a zone transfer during the footprinting stages of your pen test. It's great for finding hosts on the network that may be interesting to look at. The -n option tells Nmap never to do a DNS lookup. This can add to stealth in some cases, because if you're doing a DNS lookup, it's possible that the DNS server holder record that your particular IP address requested the IP address assignment for a certain name. Also, to speed up a network scan, since Nmap won't have to do a DNS resolution every time it hits an IP address. --P_R tells Nmap to do what's known as an ARP ping. If you're on the same LAN as a bunch of hosts that you want to scan, ARP ping is the fastest thing to do, because even if you used regular ping, you would still have to go through the ARP phase to be able to find the MAC address for that particular IP. The great thing about ARP ping is it's much faster if you're on the same local area network as the machine you're trying to scan. And by the way, that's the only time you can use it, is if you're on the same local area network as the machine you're scanning. But I've also been told that ARP ping will work if the router between you and the other network has proxy ARP enabled. Another great thing with the ARP ping is it can find hosts that are up even if they don't respond to ICMP packets because they have a firewall up. And it can't really block ARP on a local area network, because then many things wouldn't function, because the LAN has to do MAC address to IP resolution. If you're on the same subnet as the host you're going to be scanning, ARP ping is a much better option than using the -P0 command to tell it not to do a ping at all. No sense in trying to scan boxes that aren't there. Normally, Nmap is pretty good at choosing what interface to use by default. However, if you need to specify which network interface to use, for instance ETH0 or ETH1, you can use the -E option. If you want to specify a certain IP to use, then you can use the --S option. You can also specify an IP address that doesn't even belong to your machine, and they can frame another box for doing the scan. However, since none of the information is going to get back to you, you won't be able to find out what ports are open on the target. The --source_port option allows you to specify what source port Nmap will use when trying to make a connection to a host. This can sometimes be useful for getting around very crappy firewalls, because they may not do proper inspection of the packets and let something in solely based on the source port. For example, since many firewalls just let port 80 in, no matter what's coming through on port 80, you might want to try using port 80 as your source port and see what kind of network scans you can get through that you wouldn't be able to get through otherwise. Like I said before, these are just a few of Nmap's many options. Check the man page for a lot more, or Fedora's upcoming book. Click Next to continue this. Using the -S_O option will tell you what IP protocols the host supports. In this case, this JetDirect box only supports protocols 1 and 6, ICMP and TCP respectively. Click Next to continue. Here I use the -E and the --S to tell Nmap what particular network interface I want to use and what IP address I want to use. If we go in and check the firewall log on the Windows box, we'll notice I framed that IP for the port scan. Since I specified an IP address that doesn't belong to this box, I never get back any information. So I'll just use Control-C to kill the Nmap scan. Click Next to continue this tutorial. So it will tell me the host name that goes along with a given IP address. Here I do a list scan of a set of IP addresses that all belong to the same folks who own /.org. As you can see, we found a few other interesting hosts in our network. Please click Next to